is one. It's part of the sheltering complex that is involved in maintaining telomere integrity. So POP1 does this by binding with single-stranded telomeric repeats to protect the ends of the chromosomes. So defects in this complex increase chromosomal instability. Germline mutations in POP1 have previously been associated with familial melanoma, and you'll see some other cancers listed there also. Interestingly, there's been a couple of case reports that have associated with associated cardiac angiosarcomas, also with germline mutations in POP1. And heterozygous pathogenic POP1 variants result in longer telomeres in mutation carriers. So given that POP1 was part of the sheltering complex, we were interested to look at whether we had any additional deleterious variants in genes that were part of the sheltering complex also. And interestingly, we picked up some additional deleterious variants in TNF2 and TERF1, which are also part of this complex. We were interested to look at telomere lengths within the probands that were carrying these mutations within the sheltering complex genes. And indeed, we showed that those probands that were carrying these mutations had longer telomeres than the sarcoma cases that did not. We were also interested to see how this was playing out clinically. What did these families look like? So there were 15 families with mutations in the sheltering complex. We firstly looked at the pedigrees for each of these families using classic clinical criteria, and we could see that 4 of these families met criteria for familial melanoma. So not only did they have sarcoma in these families, but also lots of cases of melanoma. 3 of the families had characteristics of Champari-Leiframani syndrome, and 1 looked like a hereditary breast and ovarian cancer family. This isn't an early onset condition. The proband mean age at first cancer within these 15 families is actually 54 years. And there were many different subtypes associated with this. We didn't see the pattern in the sarcoma subtypes at all. 3 of the probands had a sarcoma as well as melanomas, and at the time that we assessed this information, about 1/3 of the first-degree relatives of these probands had been impacted and had a cancer diagnosis. So these families are displaying autosomal dominant characteristics of inheritance. And you might not be able to see the pedigree very well, but this is a representative pedigree of some of these families. We see here we had a lady with a sarcoma diagnosed at the age of 62. She had previously had a thyroid cancer and 3 melanomas. A nephew with a melanoma here at an early age, and also her son with a thyroid cancer and 2 melanomas before the age of 40, as well as various other cancer diagnoses within the families. So just in summary, the sheltering complex mutations appear to be an important cause of sarcomas, and in the cases that are carrying these mutations, we are observing longer telomeres, which probably bears some further consideration when we start to think about clinical utility. When we identify somebody at increased cancer risk due to their genotype, there's generally some probabilistic uncertainty associated with whether that person is going to develop a cancer or not. If we start to look at subclinical phenotypes, of which telomere length is a good example, then we can potentially start using this as a metric, as a more personalised risk assessment as to the likelihood that this person will go on to develop cancer. So there are several implications also for us to consider when we start to think about hereditary conditions. Increasingly, germline information impacts on treatment decisions, and that might be the case in these families. Clinical risk management is also going to be important when we think about surveillance, potentially prevention some way down the track. And of course, the minute that there's germline information available, we're not only talking about the patient that's in front of us, but their family members as well, and all the flow-on effects that occur from there. So these are all the things that we're going to have to consider when we start thinking about management of these families moving forward. I would just like to acknowledge the patients and their family members that are participating in the Sarcoma Kindred study, and of course the many people in this room and the many other supporters of the Kindred study over the years, especially David Thomas, actually, who has been the driver behind this cohort, and the many funding bodies that have supported us over